Hello, and welcome to the Master Lock Milwaukee operations. I'm Tom Schlaefer, one of the plant managers here, and it's my pleasure to be able to take you on a trip through our plant. Let me tell you a little bit about our facility here. We have about 500,000 square feet under roof, roughly the size of 7 football fields. Each year, this plant produces some 500 million components, almost 2 million a day. And within these walls, we have an unusually wide range of manufacturing processes, which we'll see shortly, including plastics, paint, die cast, and stamping. Now, it's true that Master Lock is the only North American producer of school padlocks, and we make millions of them per year. You probably know that Master Lock is an American company, and you may know that we have ISO 9000 certified facilities both here and in Nogales, Mexico. But you may not know most of the components of the 1525 school lock are produced right here in Milwaukee. So for about the price of a nice cup of coffee, a customer can buy a 1525 lock with quality and precision built in. This deceptively simple looking lock is loaded with ingenious features. Now, the 1525 lock is comprised of 32 high precision components, 30 of which are made right here at our facility. This degree of vertical integration is almost unheard of today. So as we walk through the plant, what we're going to see, rather than a single factory, is going to be more of a series of integrated factories all under one roof. So come join me. Let's take a tour of our Milwaukee facility and see how the components of the 1525 are produced.
Let's start our tour in the key and cylinder department.
Here we are in the key and cylinder factory. Here we use steel, die-cast zinc, and brass wire to make the many components that comprise the finished key and cylinder assembly for the 1525 lock.
The entire 14-part cylinder assembly is made in this factory. The plug, springs, and pins are typically made of brass. The shell may be brass or copper-plated zinc, depending upon the type of lock. Pins are precision cut to 8 different lengths and are housed within the shell, which holds 4 or more pin assemblies. All of these components must perfectly match the key profile. A keyed lock, such as the 1525, has 2 levels of security. First, the precision interface of the key as it's inserted into the plug. And second, the proper alignment between the key and each of the tumbler pins. Like most areas of the Milwaukee plant, the cylinder department makes extensive use of vibratory feeder bowls for part presentation to the automatic equipment. And talk about vertical integration, we even wind all of our own springs. Department 526, Metal Stamping.
Here we are in the metal stamping department at Master Lock. Here we take coil stock and we put it through a series of progressive dies to produce the parts that ultimately become part of the 1525 lock.
Our metal stamping factory has 15 high-capacity presses. Most of these are run around the clock to meet demand. The metal used in these presses is received in a variety of cut widths, each designed to minimize wasted material, depending upon the part's shape and size. We produce parts from mild steel, galvanized steel, stainless steel, and brass. Nothing is more important than part quality and consistency. Metal stamped parts in Milwaukee are produced to very tight tolerances, typically 3/1000ths of an inch or less. Progressive dies allow parts to be formed into complex shapes through multiple punches. An individual component may be hit 10 times or more before finally leaving the tool as a completed part. Department 528, Heat Treat.
Here in the heat treat department, we start with our fully formed shackle that's still relatively soft. We put it through our heat treat processing, and what results is a stronger, tougher, more cut-resistant shackle.
Heat treat is focused on altering the grain structure of steel to achieve greater hardness and strength. Our 4-batch process ovens treat the vast majority of the shackles produced in the plant. Department 535, Die Cast.
Here in the zinc die cast department, we start with zinc billet, and under heat and pressure, we produce the many individual components that make up the 1525 lock.
There are 24 individual die casting machines in this factory, each capable of producing roughly 20,000 parts per day, depending upon the part size. Each skilled die cast operator sets up his or her own tooling. They adjust machine parameters to meet each part's requirements. They add zinc to the melting pot. And they perform rigorous quality checks on each part multiple times per shift. This 1525 lever, for example, weighs less than 1 ounce but has more than 50 print dimensions, each of which must be controlled within 0.03 of an inch. The tooling required to produce this part was also built in the Milwaukee plant and has 3 complex interlocking cores. Parts are produced at a rate of about 1 every 2 seconds. More than 150 different die-cast parts are produced on a regular basis and many more low-volume parts on an occasional basis. Department 538, Paint.
So far in our journey, we focused mainly on metal forming processes like stamping and die casting. But now let's talk about the aesthetics of the lock. Let's visit the paint department.
The paint department is focused exclusively on one type of part, dials. These are produced in great volume, more than 10 million per year. After die casting and plating, each dial is given a coat of powder paint and then baked to cure the paint. This entire system is set up and operated by one employee. The powdered dials are routed through an infrared oven which heats the dials to over 400 degrees Fahrenheit. Powder paint is solvent-free, so there's no release of hydrocarbons or other objectionable chemicals during the process. Finished dials are either packed in boxes for use in Nogales or placed in bins for the second paint operation in Milwaukee, white wipe. In the white wipe operation, the painted dials are placed to a rotating fixture on an indexing table. As the dial progresses around the table, it receives an application of very high viscosity white paint, which fills in the recesses for numbers and tick marks. This paint is then wiped from the surface, hence the term white wipe. The resulting dials have the powder color everywhere except in the recesses where the white paint remains after the surface is wiped clean. Due to the challenging nature of the task, white wipe dials receive 100% inspection before moving to final assembly. Department 527, Plastics.
Thanks, Mike. In our plastic injection molding department, we make a wide variety of parts. Single color, two color, both functional and aesthetic.
The 1525 lock includes just 2 small plastic spacers made here in the plastics department, but other master locks include more plastic content, including the lock body of safety locks and the many types of bumpers on laminated and Magnum series locks. There are 7 plastic injection molding machines in Milwaukee, and like many departments, plastics operates 24 hours a day. Quality checks, as elsewhere in the plant, are constant, with the added challenge that many plastic parts must not only meet all dimensional requirements, the color and texture must also be just right. Department 536, Plating.
Here in the plating department, we use a variety of chemical and electrical processes to turn unplated metal parts into corrosion-resistant plated components.
The Milwaukee plant has 5 complete plating lines. These utilize metals like copper, nickel, and zinc to produce finishes that are both attractive in appearance and highly corrosion-resistant. All of our plating lines employ a 4-stage process. First, caustic wash to remove oils and contamination. Second, acid etch to activate the surface and make it receptive to plating. Third, electrodeposition of the plating metals on the surface. This bond is as strong as the metal itself and lasts the life of the product. Fourth, and finally, sealing through a variety of techniques to close up any surface porosity and maximize corrosion resistance. This is just the basic process, of course. The actual plating lines have as many as 40 individual stations. Each year, more than 100 million parts are plated on site. Department 534, Shackles.
Here in the Shackle department, we take standard steel and brass rods and turn them into fully formed and machined shackles, ready for heat treat.
Shackles are so fundamental to locks that it's hard to think about one without the other. Like other lock components, shackles must be produced to tight tolerances for proper function. Each shackle starts its life as a steel or brass rod, cut to length, machined at both ends, formed into the familiar U shape, and finally broached, which is the term used for the machining of the notch. Most shackles are then heat treated, as we saw earlier, but because this process alters the metal structure, it is generally required to bring the shackles back to their precise opening width after heat treat in a process called sizing. Except for brass and stainless steel shackles, all others are plated before becoming part of the finished lock assembly. Department 553, Final Assembly.
So now we've reached the final department in our journey. This assembly department is primarily concerned with the fabrication of subassemblies, parts received from other departments turned into subassemblies that can either be assembled in Nogales into commercial locks or, in Milwaukee, turned into retail parts on highly automated equipment.
The 1525 lock has four major subassemblies. The combo subassembly, which includes the rotation cams, the latch and lever subassembly, the outer case subassembly, and the cylinder subassembly. The first three of these are produced in this department and subsequently used either in Milwaukee or Nogales. The combo subassembly is made of 7 components, all of them produced in other departments. Naturally, these subassemblies need careful and accurate assembly, but they also have an additional challenge. They must hold together as a unit in transit either to Nogales or in secondary automated assembly processes in Milwaukee. The latch and lever subassembly has 5 components, 4 made locally. The one purchased component is a high-strength sintered metal latch, a very specialized component that incorporates geometry to prevent shimming of the lock. The outer case subassembly includes the stamped stainless steel outer case, the most visible part of the 1525 lock. All of these subassemblies, plus a variety of individual parts, are then assembled into the finished locks both here and at Nogales. School locks, which include the key and cylinder, are assembled exclusively in Nogales. Milwaukee's final assembly machine for 1,500 retail locks is a true symphony of moving parts and equipment. 57 unique stations and more than a dozen vibratory bowls are combined into a single indexing machine which produces a complete lock every 2.5 seconds. These locks require only a final cosmetic inspection and packing before being sent to Nogales for retail packaging and distribution. So it is truly a partnership. Milwaukee benefits greatly from Nogales' flexibility, versatility, and ability to organize finished goods. Nogales, in turn, benefits greatly from Milwaukee's vast technical knowledge, highly developed quality control systems, and tremendous component production capacity. It's a North American partnership that benefits everyone, especially our customers.
Thank you for visiting our Milwaukee manufacturing operations. We hope you've had a chance to feel some of the world-class manufacturing that we have on display here. We feel our technology is second to none. Every day, our goal is to build locks with the highest quality, reliability, and durability unmatched by any of our competitors. When you buy a lock from Master Lock, your locks aren't made a world away. They're made right here